In this example, we are going to try to find the exact value for a negative 5 pi over 12. And tangent just ends up being a little more challenging than sines and cosines because of the fraction. And we're going to potentially have some square roots involved, and we'll have to clean that up. So let's kind of start this process. So the first thing is to do this, we need to come up with two values that we can add them together to get this. Now, I know they're negative, so I'm going to kind of think of two negatives that are going to add together. So we're looking at a negative 5 pi over 12. And I want to break that into something over 12 plus another something over 12. And really, I just want them to add up to a negative 5. So I'm just going to throw the negatives in the front of these. And I need something to make sure that it simplifies with the 12. I need something over 6, over 3, over 4. Those are angles and reference angles that I can work with. So maybe a 2 and a 3. All right, so if I simplify that, that becomes a negative pi over 6. And this becomes a negative pi over 4. All right, so that's what we got. Because I can figure out what that is, and I can figure out what that is as an exact value with some special triangles. So I'm going to rewrite this as tangent of negative pi over 6 plus negative pi over 4. All right, now I'm going to apply the formula. So the tangent is going to equal this. So we're looking at tangent of our first angle, negative pi over 6, plus tangent of our second angle, negative pi over 4, divided by 1 minus these same two values. Over 6 times tangent negative pi over 4. Okay, so now I need to figure out what negative pi over 6 and what negative pi over 4 are. Well, pi over 6 is a 30, 60, 90 triangle. And it is, so I'm going to be pulling information from these two triangles. And pi over 6 is a 30-degree reference angle. 1, 2, 3. So we're doing tangent of 30, which is 1 over root 3. But we also have to take into consideration a smart trig class. These are our sines, and we are in the fourth quadrant on this. So cosine is the only positive. So when we evaluate this of getting a 1 over root 3, it's really going to be a negative. So that negative 1 over root 3, I'm going to convert into negative root 3 over 3, because we're going to rationalize the denominator. A pi over 4 is a 45-degree reference angle. So we are looking at this triangle. Oops, 45, 45, 90. So that's a 1, 1 root 2 are the sides. So a sine or a tangent over 45 is a 1 over 1, but it is in the fourth quadrant. So that 1 over 1 is going to be a negative. Negative 1. Okay, so those are the values that I'm going to get when I do tangent of negative pi over 6. I'm going to get a negative root 3 over 3 plus a negative 1 over 1 minus these two multiplied together. So 1 minus a negative root 3 over 3 times a negative 1. All right, so if I kind of clean this stuff up a little bit, I have a negative root 3 over 3 minus a 1. And then these cancel, and I have a 1 minus root 3 over 3. Okay, so now the next part of this is I don't want fractions within fractions, and there's a nice slick way to take care of that, and that is find my common denominator, which is 3, and multiply every single piece by 3. Okay, so I'm multiplying the top by 3, and I'm multiplying the bottom by 3. As long as I multiply everything by 3, I'm changing everything proportionally. So that what it does is it cancels those denominators and leaves me with an easier problem to work. So I have a negative root 3 minus 3 on the top, and I have a 3 minus root 3 on the bottom. All right, now they don't quite match, so I can't just cancel them. My next issue and hurdle that I got to take care of is I don't want square roots on the bottom. So I want to clear that out by multiplying by the conjugate. So if it's a 3 minus root 3, I'm going to multiply it by a 3 plus root 3. And I'm going to distribute everything together and just kind of see what that gets me. That should clean this up so I don't have square roots anymore. All right, so if I distribute the top, I'm going to have a negative square root of 3 times 3 is a negative 3 square root 3. And then if I distribute it to this, I'm going to get a negative 3 out of that. And if I distribute this one in, I'll get a negative 9 and a negative 3 root 3 again on the top. On the bottom, things are going to work out nice because of the conjugate. I have a 3 times 3 is a 9. 3 times 3 root 3, negative 3 root 3, and then a negative 3, because it'll make a perfect square. All right, so we put some of that stuff together. I'll start working across here. So we have a negative 12 minus 6 root 3 divided by these two go away. And our goal was to not have a square root in the denominator, which we're about to get. And that makes 6. And then they're all divisible by 6, all the whole numbers. So that will become a negative 2. This will become another negative 2. That'll become a negative 1. And this will become a 1. So when we finally clean this whole thing up, we get our final answer to be negative 2 minus root 3. Okay, now how do we know we're right? So the last little bit of this thing would be, I would like to know if I'm right. So I'm going to put it into the calculator and find out. So our original problem was we were doing tangent of negative 5 pi over 12. So I'm going to figure out what that value is. So I'll make sure that I am in radians. And we're going to do tangent of negative 5 pi over 12. Get some decimal. And I'd like to know if this gets me the exact same decimal. So negative 2 minus square root of 3. And if I did this right, I get the exact same answer. So I hope that helped. And that is probably about as ugly as they get, just because of its tangent. Tangent has more complicated formula. And then you have this tendency to have square roots on the bottom, but not only that, but you have fractions within fractions. So you have to clear up the fractions. Then you got to rationalize the denominator. And then it kind of gets a little bit nicer towards the end.